So, hello everybody.
Hi guys.
We are still here from Embedded World. I'm joined with Andrew from Klika. Maybe Andrew, you can introduce yourself.
Yes, sure. So my name is Andrew Mazur. I'm CTO at Klika, and I'm responsible for overall technical aspects in the company and making sure that they are in line with our growth targets. And at Klika, we develop end-to-end IoT and AI solutions for our partners globally.
That's excellent. And you're actually located here, just
Yeah.
so we can see your demo.
Exactly.
You mentioned there is something called Astra. Maybe you can talk about that.
Yeah, so first of all, I would like to say that we have a few solution accelerators. So initially, we came to an idea that developing end-to-end IoT solutions is quite a complex task. That's why we've created a few so-called solution accelerators that literally represent a set of pre-built components or templates or other resources that help you speed up the development and helps you to shorten time to market. Yeah, and Astra is one of such solution accelerators, and it's worth mentioning that Astra is built on top of AWS technologies,
Oh, that's cool.
and it covers a bunch of use cases within assets tracking. Yeah.
Oh wow, that's an interesting field. Asset tracking. I remember there was quite a lot of customers asking for like how we can track those. So,
Yeah.
what kind of solution do you provide? I mean, how do you accelerate this development?
So we've created a few components that our end customers can use out of the box. So
Nice.
we can grab almost any hardware available there on the market. Yeah. And we have created a special firmware that is built on top of FreeRTOS.
Mm.
And with this firmware, you can have a bunch of features such as connectivity out of the box to AWS over narrowband IoT or LTE Cat M1. You can have an ability to send data in MQTT packages or CoAP packages. And
CoAP,
I
nice.
propose, maybe to talk about that a bit later.
Yeah, I'm interested in this.
Yeah. I have some stuff to share. So, and what's interesting, there are some additional features to manage the battery. Yeah. To make your device sleep, to define the location, to grab the data from the sensors, if there are any, and send it to the cloud. The cloud part is represented by the CloudFormation templates. So literally, you can bootstrap the infrastructure within minutes. Yeah, literally minutes. And on top of that, we also have a web dashboard that can just visualize and show you all the data from all your fleet of devices connected to valuable assets.
Excellent. So let me summarize. So you have devices which are running FreeRTOS,
Yep.
which have applications that you provide on top of this that uses either MQTT or CoAP. And then in the cloud, you have a CDK that basically bootstraps the infrastructure needed to support all of this use case. And then on top, you will also build some applications to visualize and all that stuff.
Yes,
right? Wow.
yes. And,
That's very cool.
literally, our customers can grab all these pre-built components and on top of that implement their own business logic.
Yeah.
Uh,
So you
with
can
our-
focus only on the business logic,
Yes,
not focusing
yes,
on
yes.
random stuff. Yeah.
Yes,
Excellent.
yeah. And I mentioned that there are like a few ways to talk to the cloud and to AWS, and one of them is a CoAP protocol. And we specifically use that protocol for our use case as we work with the constrained devices.
Nice. Yes, I remember like 2015. I was kind of like exploring this for a use case, and I know like this. Yeah, it's based on RESTful. Maybe you can talk about this. But it's also intended for like when you have like a meshing network as well, right? So maybe you can give us a brief introduction, like how you went into choosing CoAP rather than MQTT, because whenever we see IoT, we always think about MQTT as application protocol.
Yeah, well, so it differs from the MQTT for sure, and for each protocol there are different use cases, and within that, based on that, you can pick and choose any of these protocols. But talking about the CoAP, there are a few features that I would like to highlight. First of all, it was built based on those REST architectures principles. So they are really widespread on the web. Yeah, and with this standard, you have pre-built and default methods as put, post, delete, and can use them. Then it is lightweight, so the protocol is really lightweight. The header overhead is approximately or equal 4 bytes, yeah, which is a few.
Yes.
Yeah, and it was specially created for the constrained devices that has some additional requirements for the low processing power, for the low battery usage, and for low bandwidth. And of course, constrained networks where the connection is not stable and there are a bunch of errors on the network. And moving forward, the third one would be, from my opinion, is based on the UDP. Yeah, so you don't need to handle a connection to the web server. You would rather connect and send the data. You don't need to go through the complex handshake procedure that consumes your energy, battery, your compute capacity, and of course your bandwidth, where you send like data to the cloud.
I mean, TCP in general is expensive, right? You have those acknowledge messages,
yeah.
all that kind of stuff, keeping the session, making sure like you have that in place. So it's interesting. This is using UDP. It's using UDP, but then again, it's similar to HTTP. So yeah, it's pretty interesting.
It's interesting.
And you would address a specific device. I mean, you probably have, how does it work? You have the address of the device, and then you can discover some resources.
So yeah, yet another useful feature is resource discovery. So there is a client and a server, and the client can go to the server, to a specific URI, and get the list of resources that this server can give you access to. So you can literally do the discovery and then just use those resources. Yeah. And maybe also interesting thing here is that the protocol is asynchronous, so you can just send the request, do not wait for the response, and just do all your stuff you need to do on the device. It's also really, really useful. And
but what about if, let's say, you have temperature readings and you want one resource to be publishing nonstop those readings? Like, how do you? I remember there was some kind of observable resource.
Yes, there is. So initially, the standard has been written within the RFC 7252 standard, and on top of that, there is a bunch of other standards, and one of them gives you ability to observe the resource. So you just, as a client, being a client, you can send a special request and ask server to notify you on the changes. So let's say you have a temperature sensor, you want to get notifications on the threshold. So you just do that, and then you're being notified.
It's the interesting thing that I find with CoAP is that you have this kind of like, the client might actually be in the cloud, and the server is actually a device.
Yeah.
So
and it can be like interchangeably.
Yeah.
The single device can be a client, a server, and
but it makes sense as well because it's serving a specific resource to be a server that's having the temperature reading. So but it's like,
for sure,
you have to change your mindset in that terms. Okay, that's pretty cool. But when it comes to security, like how do you handle that? It's talking over UDP, and I know like with TCP you have like TLS, MTLS already kind of established as a default way of securing things.
Here you have something similar. So with the help of DTLS, which is a way to secure your UDP communications, you can also handle the security aspect. So you can make sure that your data is transferred in a confident way. So and the integrity is not lost during all the way. Yeah. So it's also easy to establish. And within the CoAP standard, there are a few options. You can use pre-shared key, both on the client and the server. So in this way, the connection is established seamlessly. Of course, you can also use some tools from the PKI infrastructure. So you can either use certificates or use public-private keys. Yeah. So this way, these three options just help you to establish the security within your devices. And also there are so-called ACLs, like access control lists,
Yes.
and the server can limit the amount of resources being triggered by special clients.
Okay, so you have like for a specific client. So when they don't go to this well-known, which is one for kind of like discovering what resources a specific server has, there is a certain ACL that says, okay, for this specific client, only show this couple of resources, and then this can.
Exactly.
That's pretty cool. That's pretty cool.
Yeah.
I'm wondering why the CoAP didn't get that mass adoption as MQTT.
Well, it's only starting, as like many different devices were added and connected recently to the network, and you can see that the amount of devices is growing exponentially. New use cases are being uncovered, and that's why the adoption of CoAP is literally going on to be in the future. And moreover, it's a quite new standard. It was released in 2014 or 2015.
Yeah. I remember back then I was looking at this standard and I was like, oh, this is pretty cool. It should have been adopted. But it takes some time, I guess, for the community. But you also mentioned about the MQTT. So I know with like MQTT, you have like quality of service.
Yes.
And that stuff. So how does that work with the CoAP?
So with the CoAP, you can handle two levels of the quality of service. With MQTT, you can handle three of them.
Yeah.
So in CoAP, that would be at once, at least once.
At least once,
yeah. At least once, and
at most once.
Yeah, that would be all. Just when we're talking about the messages, I would like to comment here a bit on the amount of traffic that can be saved.
Yes.
For example, within the cellular technologies, it takes you a huge amount of money to pay for your data plans, and you would like to save this traffic. So in order to establish the MQTT connection and send your first package, you will consume approximately 75 kilobytes. Yeah?
Quite a lot.
Yeah, a lot. And I mean, secure connection. With CoAP and PTLS, it would take you like 3 kilobytes.
Wow.
Yeah, that's the difference.
Saving.
Yeah, and based on our asset tracking use case, we realized that these devices, they should sleep majority of use cases.
And battery.
It's literally like based on our statistics, every 11th package is need to be supported by the reconnect if you have an MQTT. So you can just count how many times you send and how much data you can just save.
No, this is really cool.
Yep.
Okay, I think we have a bit more time. So what is the demo that you're actually showing there? If you can briefly summarize it.
Yeah, so quickly we have devices running FreeRTOS over narrowband IoT network.
Nice.
With having the connectivity from a company called Once. Yeah. We send the data to CoAP broker, and this broker retranslate the messages to AWS IoT Core. Within the AWS IoT Core and several Lambda functions, we do the pre-processing and then store the data to the time series database. And with the help of AWS IoT core device location, we identified the location. As right now here we're at the booth, and no chance to get the perfect location with GNSS. And here we also then use Amazon location service from AWS to render beautiful dashboards, maps, yes. And of course, Amplify helps us with the application and all that stuff.
That's pretty cool. I'm going to visit and then see how this is working.
Yeah, sure. And guys, please come on and visit the booth at AWS, and we'll showcase that how it works in reality.
Yes, excellent. That's it then. Thank you so much for being here.
Thank you.